Hydrogel is a three-dimensional structure where water molecules are locked in hydrophilic polymers network, and therefore it has a superior biocompatibility. Since usually they don't cause immune rejection, they are widely used in medical and aesthetic fields. Could we replace the damaged ligament and tendon with hydrogels? Unfortunately, general hydrogels don't adhere to bones and they are easily broken. To replace the ligament and tendon, high strength and high adhesiveness must be secured, and such technology hasn't been developed yet. The hydrogel developed by Professor Jae-Yoon Kim's research team of Sungkyunkwan University provides a new alternative to making artificial ligament and tendon. They developed a hydrogel that is mechanically 700 times stronger than general hydrogels and has high adhesiveness that imitates the connective interface of biological tissues. This hydrogel is considered as a technological innovation that will lead the advancement of artificial musculoskeletal system. This new high-adhesion, high-strength hydrogel is a triple network hydrogel that combines the alginate polyacrylamide double network hydrogel whose superior mechanical properties were already proved and high-adhesion PHEA API polymers. In alginate polyacrylamide double network hydrogel, short and strong alginate polymers cross-linked in ionic bonds, and long and flexible polyacrylamide polymers cross-linked in covalent bonds are physically mixed and form amide bonds. This double network structure exhibits superior mechanical properties and resilience through efficient energy dissipation mechanism. When an external force is applied, first, alginate polymers resist it. Above the first threshold, the ionic bond breaks up and alginate polymers are de-cross-linked. And at this time, polyacrylamide polymers resist deformation. With the external force removed, polyacrylamide polymers are restored to their original forms and the ionic bond between alginate polymers recovers too. If you add PHEA API polymers to the double network structure, you can make a triple network hydrogel with both good mechanical properties and adhesiveness. A PHEA API polymer is a polyaspartamide type copolymer and has a self-healing property against an external force. And the imizidol groups at its end forms a strong hydrogen bonds with OH groups of the surface of materials. This hydrogel artificially reproduces the connective interface of biological tissues and displays great adhesion to bones and various types of substrates. The stable mechanical property of hydrogel is also maintained due to the physical and chemical bonding in triple network. This hydrogel was designed and developed with a simple and intuitive idea. A lignite, acrylamide, alginate, and PHEA API polymers are dissolved in water. Then, calcium sulfate as the source of calcium ions, an initiator, and cross-linking agent are sequentially added in the polymer solution under stirring. And the solution is poured on the surface of a substrate and irradiated with ultraviolet lights for about an hour. At this time, acrylamide monomers are polymerized to form a covalent bond, and finally, polyacrylamide is synthesized. After aging for a day at room temperature, calcium ions are diffused to form ionic bonds between alginate polymers throughout the hydrogel. PHEA API polymers are physically entrapped within the double network hydrogel structure, and as a result, a hydrogel with strong mechanical properties and adhesiveness is produced. This hydrogel has a maximum mechanical toughness of 700 kilojoules meters cubed. The adhesion energy to substrates reaches a maximum of 1,000 joules meters squared. The maximum stretchability is 3,000% and resilience is remarkably high too. Unlike general hydrogels that are easily swelled and lose adhesiveness in water and body fluid, this hydrogel retains adhesion and prevents such a high swelling. Without the complicated process of substrate surface modification, the simple method of mixing three polymers improved mechanical property and adhesiveness at the same time, and maximized production efficiency and medical practicality. Furthermore, the research team is now integrating triple network hydrogels with the super stiff hydrogel technology, which is 270 times stronger than the double network hydrogel technology. When the alginate polyacrylamide double network hydrogel is elongated, the inner polymer structure becomes linearly aligned. By forming new ionic bonds between newly aligned alginate polymers, this technology can maximize the strength of elongated direction and provide powerful adhesiveness. 2 academic papers related to this technology have been published, and 3 domestic and international patents have been registered to secure intellectual property rights. Excellent mechanical properties and powerful adhesiveness. From aiding ligament and tendon treatment to providing material for transdermal patch, tissue regeneration, scaffolds, plastic surgery implants, and wearable devices. This technology will open a new door to creating medical hydrogels of the 21st century.